So here we are once more. Middle of the second to last week. Upcoming announcements, we have an exam on Friday. Hopefully this isn't news to anybody. You're not hearing this for the first time. Exam on Friday, we have the factory lab. Did I make that due Friday or did I make that due Monday? I think I made that due Friday.
Wednesday, I think.
Did I make it Monday? Good, that's the better date. If I made it Friday, I was gonna change it to Monday. So I think what I've decided on is I'm gonna drop the second major project. And I know that may be what some people wanna hear, and it may not be what other people wanna hear, because if you're not a huge fan of the STU labs that we've been doing, that means the STU labs are gonna be a larger percentage of the overall lab grade, which may be undesirable to some people. I'll see what I can do about that, given I said there was going to be a second project.
So will the project one still be the weight of 3 labs?
Yeah.
Okay.
Yeah, I still like that as the approximate amount of work that lab was. It was about 3 of the other labs. It was a big project, so it deserves to be weighted highly. And then also to be able to curve that independently, because I also know that it was a struggle for a lot of people, but from what I've seen, people have done some really good work with it. So I want to make sure that you get a good grade for the work that you did. I will focus more on what's there than what's not there. What else? So we have that factory lab. I anticipate assigning an observer lab next week. Probably gonna be something like a Monday to Friday or Monday to Monday lab. And then I will get up a final exam study guide at some point next week as well. I think that's everything we have left in the quarter.
Final was the last day of.
Last day of finals. If this is a big conflict to anybody, if you're trying to get out of here and start spring break a little bit early, let me know, and I can potentially schedule you a little bit earlier to take the final. If that helps for moving out of places or whatever your individual situation happens to be, I will work with you to make sure that is as stress-free as possible. So just let me know what I can do and I'll try to work around it. The final for the class, yeah, so it's the Friday of finals week, which is, yeah, it's not ideal. I don't love that because it means that I don't have very long to grade them before grades are due the following Tuesday.
Can I bring up margarita mixer?
We'll figure out something fun. I'll try to do something nice for the class because that's not an ideal time to be meeting, and we're all just gonna be done at that point and waiting to get out, so I don't know, maybe I bring Costco pizza or something.
I just went to their pizza party.
You're already treating me better than work. Is the final just like the test we've had so far?
Yeah, my plan is to make it to be in detail about content since exam 3. So everything that's not on the exam 3 study guide and later, I reserve the right to ask reasonably in-depth questions about that content. And then there will be additional content that is very high level content. So I'm not going to ask you very in-depth questions about the strategy or decorator pattern, for instance, but I might do something like give you a code example of something that says this is code that could be improved by the use of a design pattern. Which design pattern would you use and how would it improve the code? And the answer to that may very well be the decorator pattern. But I'm not going to ask you to implement that. It would be more so identify and be able to explain how that design pattern would improve the code.
Do we get a note page?
Yeah, there will be I'll do sheets of paper for exams for the rest of the quarter. For both exam 3 and for the final. Other questions about schedule, where we're going, expectations, concerns about grading. I want to be as upfront and straightforward as possible so that I can eliminate any concerns. I know that you all are very stressed right now as it's the end of the quarter. There's lots that's being due, but I want to be able to at least address the concerns of the class. So if anyone has anything they would like me to address, I'd be happy to do so. Is there anything I can address to help calm nerves or any feedback you'd like me to hear about how things have been going?
So, yeah, factory observer in our final test.
Yeah. Yeah, I'm trying to make it a reasonable end of quarter. I know there's been some feedback about we should have started this earlier in the quarter. I guess I can address why we did things the way that we did a bit. Because I got feedback from prior iterations of this course that covered things like the unit testing and code smells at the very end of the quarter. The projects that people were working on throughout the quarter were poorly designed because we hadn't gone over that material. So I wanted to make sure that we addressed that material early in the quarter so that you could refer back to it as you did something like, I knew the project was coming where we were going to be using your own design patterns. So I wanted you to be able to refer to, I shouldn't implement things this way. This refers to this particular code smell that we worried about. And it's hard to create labs on exactly that material. So it kind of, we kind of had nothing assigned for quite a while, and then it kind of hit really hard in the middle of the quarter. And I recognize that's not ideal. I'll be doing some thinking over break to think about how I can better space out assignments. So it is something that I am aware of as a weakness of the class. But I also think there is a hidden strength compared to how the class has been taught in the past, and that you all had a bit more information at your fingertips when you were implementing that to be able to design it in a better way. There's always give and take. If everything that I did were perfect, man, I'd be so happy. But I fully agree, there are flaws that are embedded in that. I'll be the first person to admit that no matter how you do it, there's going to be someone who's unhappy, but I would like to know that kind of feedback. So I think next Monday as well, we're going to be spending a little bit of time. I'll step out of the room to make sure that you get the opportunity to fill out the end of course evaluations. I take those extremely seriously. So I really appreciate the time that people take to provide that level of feedback. The things that went well, the things that you feel like didn't go so well, all of that is useful feedback to me as I iterate. I'm only going to be teaching this class one more time next quarter, but that your feedback will help me to be able to design and make a few changes for next quarter, and also to pass on what went well and what didn't go well for whomever takes over the course in the future. So all of that feedback is really important. And again, I take it very seriously. So you're not just writing something that goes off into the abyss. I read each and every review at the end of the quarter and try to critically think about how I can improve the course based on that feedback. So needing to say things that went well and things that didn't go quite as well, both of those are extremely useful. Positive reinforcement and negative reinforcement are both very useful to me. All right, I spent enough class talking about that. We should dive into the command pattern that we were talking about last time. Anything else I can address before we start doing that? All right, so we were talking about the command pattern. Here is the basic UML that we described at the end of the last class. So we have a client. The client communicates with both the concrete command and the receiver. The concrete command is inherited from the command interface, and the invoker is capable of communicating with the command interface as well. We were looking at this with respect to a smart home and having some kind of programmable app or remote to be able to control all of your smart devices from a central location. So in this case, we had the receiver that was kind of the remote, or the thing that was actually doing the command. So we have the ability to make the action. Then the concrete command is the logic behind the scenes that actually executes that. And then we have the invoker that's capable of doing the logic of making sure we set up the buttons to do the appropriate logic. So we set a button to mean a particular thing. So the next thing we wanted to actually focus on is the code for how do we assign those commands to the associated slots. So how do I want to phrase it? The limitation that we're placing on ourselves is we have 7 rows of on-off buttons. And maybe this is just what happens to fit on your phone screen. If this is for the app, you don't want to have to scroll between buttons and accidentally hit a button. So the UI design that we came up with, the user interface design, is that there are going to be 7 rows of buttons. Maybe that's a physical constraint with a physical remote or a digital restraint on your phone, but we're working with, there are 7 on-off slots. So we're limited to 7 slots. The book, of course, doesn't use anything phone related, but you can imagine that this is a phone interface as well. So we're going to basically assign these on-off buttons to particular smart devices. Maybe this is the light, maybe this is a fan, maybe it's the garage door, maybe it's a security system. Who knows? It could be configured to be anything. And we're going to have the commands, the classes that we wrote that are elements of the command that are associated with each one of these button presses. When we press a button, we're going to be executing the execute command that is in each one of these subclasses. So what does the code look like that's going to be able to do this assignment? So we need a class that we're going to call remote control. It could also be phone or whatever we're using as the device to do this. And we're going to have a list of commands that are the on commands and a list of commands that are the off commands. So we're going to represent this with an array. It's an array of type command. We have a constructor. We're going to allocate space for 7 on commands and 7 off commands because that is the limitation with our space. You can imagine you could do this with an array list if you wanted to make a phone app that had the ability to add a new row and a new row and a new row and a new row, and that would just dynamically allocate memory for more and more space as you needed it. But if we're going to be limited to just 7 slots, we can use a basic array for that. So we have our list of on commands, our list of off commands. Then we need a set command method that's going to take in a particular slot that says, where are we actually going to be putting this? And then we need the on command and off command to be passed as well. So we get the index into this array that we want the on command and off command to be. So if it were the light, for instance, on the last slide, we had that in the first position. So we would have on commands of 0 equals light on commands, because we've had the on command would be passed as the light on command, and then the off command would be passed as the light off command. Finally, we have a button, on button was pushed. That's just going to figure out, all right, for a particular slot, if we have an on button pushed, what we need to get passed in is which row was it in? Was it in row 0, 1, 2, 3, 4, 5, or 6? And then we're able to execute the on command for that particular slot that's stored in the on commands list. So if button 0 was pushed, whatever command is associated with the on command in row 0 is which execute we're going to execute, and the same thing for the off buttons. So this allows us to do that assignment and then to be able to pick and choose, given a particular slot, say execute the command that's in that slot. It also allows you to swap out what's in those slots, which is really useful if you want to switch up what they represent. So it's extendable and it's swappable. Questions about this code? We have a 2-string down there too that we're not quite as worried about. All right, so here's what the light off command would actually look like. So we know that it's an implementation of a command interface, right? It has an execute function, which is what we know that every command has. We also need a constructor, an ability to create a light off command. We have a field that is the light that we're referring to with our light off command. It could be that light or another light or my light at home. We just need to know which light it refers to. When we construct the object, we pass it the parameter of the light we want to associate this button with, or this command with. In the previous slide, we associated the command with the button. So we just make an assignment to the light, and then when we execute a light off command, we turn the light off. Pretty straightforward. Another example would be the stereo on with CD command. Boy, we're dating ourselves with this book now. So in this case, we have a field that is a stereo system. When we instantiate the stereo on with CD command, we will link the field with the object that's being passed in. When we execute, we need to first turn the stereo on, then set the stereo to the CD, and then we need to set the volume to, of course, it's 11, right? Has to be greater than 10. Anyone know the reference? It's what? That's one of them, yeah. Yeah, setting the volume to 11 is a, I can't remember the name, but it's something. I'm dating myself even by, it's so long ago that I don't even remember what it is. So you can see how different kind of commands are made. Execute can do more than one thing. It may just do whatever is needed to set up the smart environment. It may not just be an on and an off. There may be more things that you need to do to turn something on to make it do what the command is supposed to do. You could make stereo on with something else, with radio command as well, if you wanted to turn on the stereo and have it play the radio rather than what's in the CD changer. Man, that's dating myself. How many of those exist anymore? My parents have them. All right, once we've made all of these commands and been able to assign them to buttons, we need some kind of driver class to be able to test all of this. So here is what a driver class might look like. If you will zoom in for me. So this is going to do the entire process of loading the remote with everything. So we make a new remote control object. This could be a phone object if we're in the 21st century. We make the remote control object. We're going to make objects for each smart device. So we're going to have a living room light, a kitchen light, a ceiling fan, a garage door, and a stereo. And each of those are going to be strings that are passed in to be able to distinguish which kind of, for instance, if we have two different kinds of lights, we now have a string to differentiate the living room light from the kitchen light. So those are all of the devices that we're going to have in our smart device. We now need to create commands for each of these devices. So we're going to have light on and light off commands for both the living room light and the kitchen light. So we pass in a particular object that we're going to associate with the fields in those commands. So now the living room light on object turns on the living room light. The kitchen light on command turns on the kitchen light because we passed in the associated object that command is going to run on. We do the same thing for the ceiling fan. The on command and off command work for the one ceiling fan that we have. The garage door up and the garage door down are now the on and off commands for the garage door. On would be up, off would be down, or you can do that vice versa, doesn't really matter. Then we would have a stereo on with CD command and a stereo off command that turns the stereo on and off. So that's the driver class. There's a little bit more to it. If I zoom out just far enough, there we go. We then want to make sure we set the commands. So we want to, on the remote control, set row 0 to be the living room light. So we pass it both the living room light on command class and the living room light off command class that associates the on command with the on button in row 0 on our remote, the off command with the off button on row 0 of our remote. We do the same thing for the kitchen light in row 1, the ceiling fan in row 2, and the stereo, I guess, in row 3. We forgot about the garage door. That's fine. We don't care about it anyway. Printing the remote control now calls the toString that we kind of skipped over to be able to show that. We can then basically push each of these buttons on the remote and see what happens as we execute those commands. And if we scroll down to the output of what we would expect, we see the toString of what's currently loaded in each slot. And then as we start executing the commands, we start printing things like the living room light is on and then off. And it wouldn't be too bad to go from just printing to the string or to the screen to be able to control a device if we just had the logic for controlling that device. There's nothing more complicated in this. The command pattern is still the command pattern. Nothing of the design of this needs to change. We would just need logic for actually turning on the device, rather than printing the device is on or off. But it doesn't affect the design pattern at all. Questions about the driver class and how the driver class shows what we did to the remote and how we executed the commands and how our code was structured to make this possible? Seems like no. Clear enough? Okay. Can't even think of any potential issues with this.
If there's more commands than buttons.
More commands than buttons, need a bigger remote. Walk into class and be like, you know what I have at my house? This many smart devices. It's my remote control and my walking stick. That's a very valid point. Any other potential issues? This is the big one. We don't know if a command is loaded or not. If we press a button and there's no command loaded in that button, it's not that nothing happens, we actually get a null pointer exception. Because there's no command associated with it, and we are automatically dereferencing, assuming that there's a command loaded in that slot. So we would need something like this in every single button was pushed method, which there would be 2 of them in every possible class associated with a particular smart object. So we would need to check for null, and only if it's not null, then execute. And that way, if it is null, then you would press the button and nothing would happen. It wouldn't try to execute the command because the command has nothing in it. There's no object associated with that button. So that would work, but we have to do it in every time a command is loaded into the remote, which is potentially quite a few times.
If you have like a default thing that doesn't command, does nothing, you just fill it up at the beginning.
That's exactly where we're gonna go. We're gonna make a command that is a do nothing command. Yep. So we want a command object that is a do nothing command. And you see this in design patterns a lot. We're gonna make an entire object whose purpose is to do nothing. We're gonna design a class for an object that does nothing. Design patterns are wonderful. It works, but it's a bloated answer to the problem, which just kind of shows the kind of detriments we get by incorporating design patterns. So we load this empty command into each slot by default, and then if there is no command in the slot, then pressing the button doesn't cause the program to crash. So we'll just make a no command class that implements the command interface. We define an execute function that does absolutely nothing and call it good. In our driver program, we make a command no command, and then we just, whenever we initialize the remote control, we're going to, for each slot in the remote control, load no command into every on command and off command. And that's part of the remote control construction process. Whenever we make the remote control, the default on-off buttons do nothing. It would really suck if you had some kind of application, you pressed a button on your remote control and the entire system broke. You have to go unplug the smart device and plug it back in to reset it. Before you load the commands back into it, before you can operate the system again. That's a bad system. You would rather have a system do nothing by default. Questions on this? I think the way that you identify something like this is you start thinking about what is the default behavior? What happens if I haven't done anything yet? So this becomes a kind of corner case or an edge case that becomes something that you want to think about in your design. In the same way that you think about what happens if I pass this particular method 0 or a negative number when you're writing unit tests for it, start thinking about what happens if this object is null. Does it crash my program? Do I need to do something that does not, is there better behavior that does not crash my program that will make the user happier with me? Think of the user like a finicky 2-year-old that's always upset by anything going wrong and you can't go wrong there. Just assume that your user is an idiot, doesn't know what they're doing, and if something does go wrong, they're gonna throw a tantrum and sue you at the same time. All right, we mentioned at the beginning of this that we could implement undo with command. So let's actually go through the logic of adding undo to our remote as well, where there's a particular undo button at the bottom, and whenever we press it, whatever the last command that we did, we're going to undo that, do the opposite command. So if we gave an on command for a light, the undo button will give the off command for that light. If the garage door up was called, then the undo button will whatever we call the garage door coming down is, we'll call it that.
One that just uses stack.
We're gonna load a most recent command, basically. So you could use a stack to be able to do undo, 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 if you wanted to be able to undo any sequence of things, but the actual better way to implement that is actually with a different design pattern called memento. So there are actually two different design patterns that support undo. Command is one of them, memento is the other. If we have time, I'll go over memento next week. So undo is the last thing we need to do to have a complete working system here for our command. So where should the undo be done? Think about this with the person next to you. Where in the code would you implement undo? Where does it belong in the structure of what we have thrown together so far?
There's no command when the undo buttons will be by itself too.
Yeah, we need some kind of basic undo nothing is nothing. Special case.
And then probably later have redo.
Redo is harder with command. Redo is much easier with memento. Because if you undo the undo at this point, you're basically doing a redo. But you only have kind of that one. Yeah, you can't remember a history of things really easily, because if you undo the undo, are you asking it to redo? Or are you asking it to undo the second last thing? We have a little bit of issue there about.
You have to have some kind of memory implementation.
Right, that's where a stack would be very useful.
Like on, undo.
Any ideas? Where would you put this?
I think you just add a button that has a command that you set every time you execute a command as the opposite of that command.
How would you know what the opposite is? Where would you implement what the opposite is?
When you do the command, you last do, like each command would have.
Yes.
set this variable to-
Yes, that's the important idea here, is that every single command object needs to define separate behavior for what undo means. Since that's the case, then undo actually belongs in the command interface. Yeah. So we're gonna specify that in order to be a command, we must define what it means to undo that command. And then all of that logic will be in all of the command subclasses that inherit from that implement that interface. So, yes, add it to the command interface. So now in addition to an execute, every command must also be able to undo. We don't specify what that undo means at the interface level, but we then need to implement it in each subclass that implements that interface. So for something like the light on command, we will implement an undo method that turns the light off. When we execute the light on command, we turn the light on. When we undo the light on command, we turn the light off. When we have a light off command, execute for the light off command turns the light off. Undo for the light off command turns the light on. Note that this only works if there's a binary system, if we're doing the opposite thing, but the undo method, we have the ability to make any logic in there that we want. So we could represent more than just the binary on-off situation of whatever tasks we need to do to undo something. So maybe the stereo on says, turn the stereo on, play it or quit CD, plays the CD. And off now just turns it off. It's not exactly the opposite, but we get the ability to define what that behavior is in that undo method. All right, great. Now we need a way to track the undo. If we have all of this logic, we're not quite done yet. Why not?
You can say what the last command was.
Yeah. We need to figure out what the last button that was pressed was so that we know which of these many possible undo methods that we need to call. If the last thing we did was turn the kitchen light on, undo turns the kitchen light off. We know that we stored in that subclass kitchen light on what undo means, but we don't know what command was last done. So we need a place kind of at the global scope that shows this is the last command that was executed. Whenever we execute something, we need to overwrite the thing that we last did with the thing that we're doing. Oops. How would we do that in code? I gave you the answer in English, but where does it belong in the code?
In the button. Like the press button.
The press button?
You say the last command in the next to the variable.
All right, I like it. I like it. Any agreement, disagreement? I like it. If you didn't agree with yourself, I start to question your sanity a little bit.
Error. So
I'm my own harshest critic. Everything I say is wrong. So we are going to do it in the remote control. Now we're going to call this class remote control with undo to show that it's slightly different. We're replacing the remote control class with remote control with undo just to differentiate. If you look back on this, the remote control class doesn't have the undo functionality, but it belongs in the same place. We're not using both of these classes. So we still have our list of on commands and off commands, but now we're going to have a command that is the undo command as a field. And that's going to be stored as a particular command as the opposite command to whatever the last command that was executed was. So when we make this, when we call the constructor, we'll set the on commands and off commands to, again, no command. But now the undo command is also going to be a no command. That makes sense, right? If the very first thing you do when you buy the remote is to spam the undo button, you want it to do nothing. Set command now says we're going to take a slot, we're going to take an on command and an off command, nothing changes there. We set the list of on commands and off commands to be the list that we passed in. Great. When we push an on button, We're gonna execute the on command to the appropriate slot. And then the undo command is gonna be set to the same thing that we just did. That represents the last thing that we did, so if we ever want to undo, then we want to execute that command that we're storing in the undo command. Last thing we did is the thing we want to undo. Whenever we push an off button, we want to execute it and store it in the undo slot. If we have now an undo button was pushed, then we want to just execute the appropriate command, the undo command. Whatever command that happens to be, there is an undo that defines the behavior to undo it. Does this make sense? Yeah,
So, you create undo command equals no command in a constructor.
yeah.
When trying to access the undo function when pressing the undo button, would that be illegal?
We would have to redefine the undo command to also have an undo in addition to the execute. You wouldn't be able to have an undo command inherit from that interface. Once we say that interface has to have an undo, you'd also want to define the no commands undo to do nothing.
Okay.
Great point, though. That's not something that we went over, but it is something you'd have to change to be able to have this undo. If you didn't have that, you would have an error of you can't implement this interface without specifying what undo does. Great point. So we can again make a driver class, a remote loader that now tests undo. So here's what this test might look like. Again, if you're using this or writing this as a test, that's probably the best way to do it. The book always assumes that you have some kind of driver class, but this is best implemented just as a unit test that you would add to your unit test repository that makes sure, or suite, to make sure that the undo button works correctly. So you would do something like, we'll make a remote, we'll make a living room light. We will define the on command for the living room light and the off command for the living room light. We would then set the commands in the remote to say row 0 controls this light. We then want to push the on button, push the off button, figure out if that worked. Undo the off and make sure that that turns it back on. Then you want to turn it off, turn it on, and undo it, and you want to make sure the opposite of on is off again. So you have an undo of off to on, and you have an undo of on to off. So that fully tests the undo for both cases of the light is on and the light is off. It wouldn't be complete if we didn't handle both of those examples, right? If we tried to undo with on, if we made a mistake in the undo of off, we wouldn't catch it. And if we tested the undo with off without testing the undo of on, we wouldn't necessarily catch it if there was a mistake in that. So we want to make sure we test both. What happens if the light is on and we undo? What happens if the light is off and we undo? So here's where we see it all. We see that everything works the way that we would expect.
If you hit undo twice, it's gonna try to do the same thing.
It would swap back and forth.
Do you swap the command?
Yeah. Yeah. When you undo, you actually execute the undo, which then in the remote control sets the last thing that we did as the undo.
Windows 98.
Yep. But as Jimmy mentioned earlier, there's a bit of an ambiguity if you had a more complicated, that was not binary. Do you want to, if you hit the undo button twice, are you undoing and then redoing, or are you undoing and then undoing again to go back to spaces? If you have something that complex, don't use this pattern, use Memento instead.
It's kind of like Boolean style, like you flipping to the previous, right? You had it like on off switch, it will be back to the opposite. That so
Yeah. All right, ceiling fan. has more than just on and off. It has a bunch of different potential speeds. I think it had 11 speeds or some number of speeds, doesn't matter. But if you undo something like setting your ceiling fan to speed 7, we need to store, it's not just on and off, you need to store the actual state of the object. So undo is a bit more complicated than just being able to call a particular execute. So let's first take a look at what this looked like before. We have the ceiling fan. Oh, it only has 4. Off is 0, low is 1, medium is 2, and high is 3. So we can turn it on and off. We can also set the speed to 1, 2, or 3, given that it's on. So this just makes sure that we have the functionality for the fan. There's no undo in this object. Off turns it to off. Low and medium and high turn it to low and medium and high. What do we think the after code looks like? Let's take a look at it. So we need a field to store whatever the previous speed used to be. So rather than just being on or off now, we need to figure out what that speed is. And now the undo method is no longer just executing either on or off. We need to take a look at whatever the value of the previous speed happens to be. And if there are lots of different options there, this if, else if, else if, else if block is going to get really large. Maybe there is a design pattern we could use to get around that big if, else if, else if, else if block. But now we're starting to bloat our code quite a bit to just be able to get rid of this particular block. But for now, we'll just think about this as, this isn't too bad with just 4 possible blocks here. So whenever we execute, we need to set previous speed to whatever the speed happened to be before we did it. When we undo, we will query what is the value of previous speed. Whatever that value happens to be, that's what we set the fan speed to. So we call the appropriate method to undo what we did. But note that we're not storing anything when we do it, so we can only undo once, at least with this implementation. As we do this, we should be setting prev speed each time we set it to high to say prev speed was whatever it was when we call the get speed right now. Before we set ceiling fan.high, we should be calling ceiling fan.get speed and setting that back to prev speed. So I don't fully like this implementation, but it does the trick for a single undo. Questions on this logic? We'll make a driver program. You could think of this as a unit test. We are just going to make a ceiling fan. We'll make commands for each of those associated speeds. So there is a command for setting it to medium, high, low, off. You will set the associated commands. Note that we need multiple rows now to represent the ceiling fan at different speeds. So row 0 turns the ceiling fan to medium or off. Row 1 sets the ceiling fan to high or off. Maybe it would be nice to have a bit more of a customizable approach to this. Rather than having a physical remote, this is what's nice about having an app on your phone is if you set something like a ceiling fan, instead of having an on and an off, you could dynamically have off, low, medium, high, or high, medium, low, off, and have there be 4 buttons on that row. Physical devices are very limiting. If we execute all of this in this associated order that should really be in a unit test, we see that it prints out the appropriate things that we might expect, and it works. what is something that would be really cool? If you're the designer and designing all of this, is there additional functionality that you could implement with this design pattern? In addition to turning on and off individual elements of your smart system, what additional buttons could you invent that would do cool things?
For a ceiling fan or?
Anything for your own smart home with all of your smart devices. Think of you after you graduate, you get a cushy six-figure job, you buy a house, even with these stupid prices that there are these days, you have a job that makes you enough money to eventually buy a house and then outfit it with all the coolest smart toys. What could you do?
You could have like an entering the house and leaving the house function.
Yeah, so what happens when you enter the house? You want to raise the garage door, turn on all the lights. When you leave the house, or like maybe when you go to bed, you want to make sure the garage door is closed, all the lights are off, all the ceiling fans are off. Something like this. We're going to call this a macro. That's exactly where we're going. We want to be able to do multiple of these commands and store these list of commands and give them a name. So single button on the remote to do multiple things. We can make a macro command object and its own interface that basically says, a macro command is a type of command that now, instead of being constructed out of a single command, is now constructed out of a list of commands. And we have a field that stores a list of commands. Execute for a macro command, now instead of executing a single command, loops through every element of this list and executes each one of those commands.
Just before they had the advanced for loops.
I think the book doesn't assume that you know, and they have a standard representation, but yeah, this should be a for each loop. For command C in commands. Yep. So that's a macro command. Then we can test this or show it by basically saying we're going to have a living room light, a living room TV, a living room stereo, and a hot tub. We can set commands for turning the lights on, the stereo on, the TV on, and the hot tub on. We can now make a party on and party off macro that starts the party when everybody arrives and stops the party when everybody leaves. That turns on the lights, the TV, and the stereo and the hot tub. And now it's a party. When everybody's gone, you turn all of those things off, the party has ended. We can then set that on the remote where we have an on, that is the macro that turns all of those things on to start the party, and another button that turns it all off and ends the party. So here is a unit test that would be able to determine whether or not this macro was working correctly. Kind of running out of time. So other things we can do with the command pattern. We can group any computation together. Anytime we have a receiver and a set of actions, we can now pass that between different elements in a program. So command is very good for packaging up these sequence of commands and sending sequences of commands to different parts of your program. Note that the execute does not have to happen right away. You can delay the execution for a little bit or a longer period of time. So this could be useful for things like scheduling. If you wanted to make a command that was something like a room reservation system for one of the conference rooms upstairs, or a scheduling system for when the computer science courses are going to be offered and what classroom they're going to be in, you could use the command pattern for all of that assignment. Job pools, you could use it for multi-threaded applications. Logging requests in a backend system and a database. So requests to be able to handle those. You could get a list of commands, and then as you have the space to be able to do those commands, grab a command from the command queue and then execute that command. Once that command is done, grab another one, and then if you had multiple threads, each thread just goes and grabs from the associated queue, whatever command is next in the queue. So we can store them in a queue. Whenever a thread is ready for something, it goes and grabs it and begins working on it. And very finally, as they're executed, we can start to store a history of them in a log file. If a program crashes, you can, rather than fully crash the program, you just go back to that log file, execute all the commands in the history list, and get yourself back to where you were, and the user doesn't even know something happened. So you have a way to recover your program in a way that's not even necessarily visible to the user, which is cool. So all of those are potential uses of the command pattern. We're out of time. I'm anticipating tomorrow to be either work day or problem day. Does anyone have, whether you prefer to spend some time working on the factory lab that's been assigned? Yes? All right, we'll do that. I'll answer people's questions. Try to get stuck between today and tomorrow, and I can try to help out with that. So I can also answer any exam related questions because by tomorrow, I'll have made the exam.
I think you can also post the factory slides and.
Yes, that's quite behind. Yeah, I will go back to my office and post slides immediately.
Thanks, so.
Thanks for letting me know. See you all tomorrow. That's what.